Oh, all right, everyone. Hello and assalamu alaikum. We're starting. So today we want to do difficult questions from two papers, November 2020 paper 1-2 and paper 1-3. These are the two papers that we want to discuss today. Only the difficult questions. I posted a poll on the WhatsApp group earlier as well. I hope most of you have responded to that. We'll have a look at that. There were not many votes when I looked at the last time. Please make sure to submit that poll as soon as possible so we can decide which questions we want to do from these two papers. Yeah, so I don't see many votes there still. So if you haven't had the chance to attempt the paper yet, I think at least what you should do is skim through the questions now and let me know the questions that you find difficult so that later on when you actually attempt the paper, if you haven't already done that, we have already discussed the more difficult questions at that point. Yeah, so I still don't see many people there who have responded to that. Can everyone please do that? Have a look at the paper, November 2020, paper 1-2, and let me know the questions that you find difficult. Okay, so we're going to start now. Do that for the second paper as well. Now I will start with question number 3 from this paper first. And then in the meantime, hopefully, I would have more responses on that poll as well for the rest of the questions. And then we can decide which other questions we want to do from this paper. We're going to start with question number 3 first of all. That has the most number of votes for now. While we do that, please have a look at the rest of the paper as well and let me know the questions that you find relatively difficult. Okay, so let's start with this one. Question number 3. It says the equation of a curve is this: y equals 2x squared plus m into 2x plus 1, where m is a constant. And the equation of a line is y equals 6x plus 4. Show that for all values of m, the line intersects the curve at two distinct points. Okay, now, what do we understand from that? We've got the equation of a curve. The equation of the curve looks like this: y equals 2x squared plus m into 2x plus 1. And equation of the line looks like this: y equals 6x plus 4. These are two functions that we got. Okay, we need to show that no matter what the value of m is, the line would always intersect this curve. Now, how can we do that? Generally, in questions like these, they ask you for the set of values of the constant where the line would intersect at 2 points, right? But here, they're not asking you for the set of values. They're asking you to show that it's always true. Now, how do we do that? The line intersects the curve at two distinct points. When does that happen? That happens when b square minus 4ac is greater than 0, right? We're talking about quadratic function here. This is a quadratic function. So when you start solving it simultaneously, you would end up with a quadratic function from that. They're saying this quadratic function is supposed to have two solutions, always. So that's what we need to show. We need to show that. It's not given. We need to show that the line intersects the curve at two distinct points, no matter what the value of m is. This is what we've got to do. We've got to show that b square minus 4ac is greater than 0 all the time, okay? No matter what m is. How do you do that? You start using the same process that you normally do for problems like these. You equate both the functions, and that will give you a quadratic function. Let's see what we get from that. Since we have y as a subject in both equations, what we can do is we can just equate them directly, and that will give us 2x squared plus m into 2x plus 1, that equals 6x plus 4. That's the equation that we get. That's how we find points of intersection of two functions. Now what we do is we take everything to one side, and that gives us 2x squared plus 2mx plus m minus 6x minus 4 equals 0. And now we write the like terms together. We only have one x squared term, so that's 2x squared. There are two x terms. We've got 2mx and minus 6x. What we do is we take x common, and that leaves us with 2m minus 6 inside. So 2m minus 6 into x plus the constant. The constant terms are m and minus 4. So it becomes m minus 4 equals 0. This is what we get in the standard quadratic form, right? Ax squared plus bx plus c form. And now we can say the value of a is 2, the value of b is 2m minus 6, and the value of c is m minus 4. What we need to do is we need to show that b square minus 4ac is greater than 0. Let's find b square minus 4ac and see what that is. B square minus 4ac in this case, that's going to be 2m minus 6 whole squared minus 4 into 2 into m minus 4. This is what b square minus 4ac turns out to be. Do not put this do not put this greater than 0. You do that when they give you that the line intersects the curve at two distinct points. When it's already given in the question. It's not given in this question. You have to prove this. You have to prove that b square minus 4ac is greater than 0. So you don't start by putting this whole thing greater than 0. That would be wrong. You find b square minus 4ac first. Let's simplify this and see what we get from this. And then we have to prove that this is always greater than 0 somehow. Let's try that. 2m minus 6 whole squared, that simplifies to 4m squared minus 24m plus 36 minus 8 into m, that will be minus 8m, minus 8 into minus 4, that will be plus 32. Okay, let's simplify this. This gives us 4m squared minus 32m plus 68. This is the value of discriminant. This is b square minus 4ac. We need to show that this is greater than 0. How do we do that? This is also a quadratic expression, right? This also has m squared. It's a quadratic expression. What's the shape of this quadratic expression? Remember, this is b square minus 4ac. We're not talking about the original curve. We're talking about b square minus 4ac from that equation. What is this going to look like? It's also a quadratic function. It's going to be a U-shaped function, right? It will look like this. U-shaped like this. The curve for b square minus 4ac. And it would have some minimum point. This would be the minimum point of b square minus 4ac. If we can find the minimum point of the discriminant, and if that turns out to be positive, we can say since the minimum value of b square minus 4ac is positive, b square minus 4ac is always greater than 0. So what we can do is, we can find the minimum value of this thing. How do we do that? We could, it's a quadratic expression, right? We could use minus b over 2a. We could complete the square, anything that you prefer. Let's use minus b over 2a and see what the turning point turns out to be from that. H equals minus b over 2a, right? H is used generally to denote the x coordinate of the turning point. Minus b over 2a, let's see what we get from that. In this case, this is b, so that becomes minus into minus 32 divided by 2 into 4, and that gives us 32 over 8 to the 4. This is the x coordinate of the turning point. All right. What about the corresponding y coordinate? We put that value of h, or in this case m, inside this function and see what that gives us. The corresponding value for k turns out to be 4 into 4 squared minus 32 into 4 plus 68. What's that value? 64 minus 32 into 4 plus 68. That's also turning out to be 4. So that means the turning point of this discriminant, the minimum point of this discriminant is 4, 4. What's the y value? 4. So we can say the minimum value of b square minus 4ac is therefore 4, because minimum is 4. So this function b square minus 4ac is always greater than or equal to 4. That's what we understand from this minimum point. So the minimum point is 4 and 4. This value 4 tells us that b square minus 4ac therefore is greater than or equal to 4. Or we can say, let's write that in words, minimum value of b square minus 4ac is 4. What that means is b square minus 4ac is greater than 0. It's always greater than 0. No matter what value of m you input there, since the minimum value of b square minus 4ac is 4, that means it's always greater than 0. Since it's always greater than 0, we can say the line intersects the curve at two distinct points. Okay, so this implies line and curve intersect at 2 points. This is what we had to show here. This is one way of doing this. You could also do the same thing by completing the square. You could say b square minus 4ac turns out to be 4m squared minus 32m plus 68. Another way to think about this could be that you complete the square for this. Take 4 common. What does that leave us with inside? M squared minus 8m plus 68. Divide 8 by 2. That will give you 4. Add 4 squared, subtract 4 squared. Now, you can keep 68 inside as well if you want, but it doesn't really matter. You can keep it outside as well. This gives us 4 into m minus 4 whole squared minus 16. Outside, you've got 68. Now, let's simplify this. This gives us 4 into m minus 4 whole squared minus 64 plus 68. And that gives you 4m minus 4 whole squared plus 4. And that also gives you the same turning point. That's 4 and 4. You can also understand from this expression that this is always a square. This is a square, so that's always going to be greater than or equal to 0. It can never be negative, right? 4 is a positive number. This is a square. This whole thing can never be negative. And you have plus 4 added. That means b square minus 4ac as a whole is going to have a minimum value of 4. Since the minimum value is 4, b square minus 4ac is always positive, and that is what we had to prove there. You could do it any one of these two ways. You could either use b over 2 minus b over 2a to figure out the turning point, or use completing the square. Is that okay? Any questions on this? No problems? Okay. Now let's have a look at the next question then. Again, just a reminder to respond to that poll if you haven't already for both the papers. Okay, now let's have a look at the next question then. The next one, let's do this. Question number 4. Let's do that next. That also has a few words. Yeah, okay, let's do that. Question number 4. Let's move on to the next one. Now it says the sum Xn of the first n terms of an AP is given by this. The kth term in the progression is greater than 200. Find the smallest possible value of k. Okay, now how do we think about this? Sn is given, okay, and it's an arithmetic progression. What are the parameters of an AP, of an arithmetic progression? How do we describe an arithmetic progression? We need the first term and the common difference. Can we find both of those things from this formula? We can do that. We can say since Sn is equal to n squared plus 4n, let's input n equals 1 in this. What does that give us? S1, that equals 1 squared plus 4 into 1, and that simplifies to S1 equals 5. Sum of the first term, that is 5. Now, what does that mean? Sum of the first term, that's basically just the first term. This is going to be the first term, okay? Now you input x, n equals 2. What does that give us? S2. That gives us 2 squared plus 4 into 2, and that will give you sum of the first two terms. What does that turn out to be? 4 plus 8, that is 12. So the first term, therefore, is 5. If S1 is 5, that means the value of the first term, that is 5. S2 is 12. What does S2 represent? S2 represents sum of the first two terms. That means T1 plus T2, that is equal to 12. Now we know the value for T1. T1 was 5. So 5 plus T2, that equals 12. So the value of T2, therefore, should be 7. So we've got the first two terms of the sequence. T1 is 5 and T2 is 7. So now we have this AP such that the first term is 5, the second term is 7, and so on. So now do we know the first term? The first term is 5. What about the difference? Difference is 7 minus 5, which is 2. So now we've got both of those things for this arithmetic progression. We know what the value of A is, and we also know what the value of D is. Okay? All right. Next, it says the kth term in the progression is greater than 200. So there's some term that we're saying is coming at the kth position. That term has a value that's greater than 200. So what we understand from that is TK, that's what the kth term means, right? That is greater than 200. Now, what's the term formula for an AP? The term formula for an AP looks like this: A plus n minus 1 times D. We are talking about TK. We can just input K instead of n, and that gives us A plus, so A is 5, plus n minus 1, that means K minus 1 times the difference, that's 2, that's greater than 200. And from this, we can find the value of K. It gives us 5 plus 2K minus 2, that's greater than 200. And that gives us 2K greater than 197. And that will give you K greater than what? What do we get from this? 98.5. So K is greater than 98.5. Now, what were we looking for? We were looking for the smallest possible value of K. Now, if K is greater than 98.5, what's the smallest possible value of K? So, K represents the number of term, right? At which position the term is appearing. So it has to be an integer. What's the least value greater than 98.5? We would say that is 99. That's the value of k that we were looking for. Okay, that's the least k, 99. Any problem with this? Mariam, your voice is really low. Can you speak up a bit? Were you asking something? I can't hear you clearly. Could you repeat your question? Why did we do T and T2 as well? Well, the formula says Sn equals n square plus 4n. This is the sum formula for this arithmetic progression. What does that mean? If we were to input n equals 1 in this, that will give us S1. What does S1 mean? Sum of the first term. Sum of the first term, that's basically just the first term. That's 5. Then what we did was we input n equal to 2 here. What is n equal to 2 supposed to give us? When we input n equal to 2 in this, we get S2. S2 is 12. S2 means sum of the first two terms. That means the first term and the second term. Their sum is supposed to be 12. If the first term is 5, and the sum of the first two terms is 12, that means the second term, therefore, is going to be 7, because 5 plus T2, that will be 12, and T2 turns out to be 7 from that. Okay, so this is the sum formula that we're given in the question. So when we input n equals 1, that will give us S1. When we input x equals 2, n equals 2, that will give us S2, and so on. All right? Okay, let's move on to the next question. Okay, so what's the next one? Okay, so next one from this paper is question number 10. Let's have a look at that now. Question number 10 from this paper. Right, yes. Okay, let's try this. The diagram shows part of the curve y equals 2 over 3 minus 2x whole squared minus x, and its minimum point m. You see this minimum point here, which lies on the x-axis. Find expressions for dy over dx, d square y over dx square, and integration of integral of y. Okay. Now, how can we do that? First of all, let's write this function in power form. So it becomes 2 into 3 minus 2x whole raised to power minus 2 minus x. And now let's differentiate it first and see what dy over dx turns out to be. 2 into minus 2 into 3 minus 2x. Subtract 1 from the power, it becomes minus 3. Multiply by the derivative of what is inside, that is minus 2. And minus x, what's the derivative of minus x? It's minus 1. So that's dy over dx. Let's simplify this before we differentiate it again. It becomes 2 into minus 2 into minus 2, that will be 8 into 3 minus 2x whole raised to power minus 3 minus 1. That is dy over dx. Now we need to find the second derivative. Let's differentiate it once more. That will give us the second derivative, d square y over dx square. Let's see what that turns out to be. Multiply by the power again. Subtract 1 from the power. So it becomes minus 4. Multiplied by the derivative of the base, that is minus 2. And the differentiation of minus 1 is 0. So that gets ignored. Now we multiply this. 8 into minus 3 is minus 24. Into minus 2, that's 48. 48 into 3 minus 2x whole raised to power minus 4. That's the second derivative. Okay, you can write this in the denominator if you want, or you can leave it like this, and that's perfectly okay. You've got the first derivative and the second derivative. Now, the third thing that they wanted from you was integration of this function. Now, let's integrate it. integral of y with respect to x. That means integral of 2 into 3 minus 2x whole raised to the power minus 2 minus x with respect to x. Now, how do we do this? 2 is multiplying, that remains as it is. This is a linear expression with a power on top. Add 1 to the power, it becomes minus 2 plus 1, which is minus 1. Divide by this new power, which is minus 1. Divide by the derivative of what is inside, and that's minus 2. That's the integration of this first term. What's the integration of minus x? You add 1 to the power, divide by that new power. Okay, that's your integral. And now, since we are integrating, whenever we integrate, we also need to put a plus c there. So we have a plus c at the end. Now we simplify this. 2 and minus 2, they get cancelled. Sorry, 2 and 2 get cancelled. And we have minus and minus, they become plus. And we're just left with 3 minus 2x whole power minus 1 for the first term. Minus x square over 2 plus c. If you want, you can write it like this. 1 over 3 minus 2x. Because the power was negative, we could take that to the denominator. Minus x square over 2 plus c. That's the integration of this function. All right, so that's all that we had to do in this part. Just find dy over dx, d square y over dx square, and the integration of this function, integral of this function. Now it says find by calculation the x coordinate of m. Now what is m? M is this point here. That's the turning point of this function. How do you find the turning point of this function? You can put the derivative equal to 0. Okay. One way to do this could be to find the x-intercept of this original function as well. You could put y equal to 0. And you could solve that equation. That should also give you m. Or you could put the derivative equal to 0. That should also give you this point m. Let's see what is going to be simpler. If we put the original function, y equal to 0 in the original function, that will give us 2 over 3 minus 2x whole squared minus x. And we'll have to solve this equation. If we put the derivative equal to 0, that's going to be something simpler because we have a constant as the second term. That's going to make things simpler. So let's actually use the derivative here. Instead of using that curve, m is the turning point, right? Yeah. So we've got dy over dx. What was dy over dx? Dy over dx was this expression. We could write that as 8 over 3 minus 2x whole cube minus 1. Since we're looking for the turning point, we put the derivative equal to 0. So it becomes 0 equals 8 over 3 minus 2x whole cube minus 1. 1 goes to the other side, and it becomes 1 equals 8 over 3 minus 2x whole cube. Now we can cross multiply this thing on the other side, and that gives us 3 minus 2x whole cube equal to 8. Take cube root on both sides. 3 minus 2x equals 2. And then 2x equals 1. And x equals 1 over 2. That's the x coordinate of that point m. Right? That was the turning point. That's all that we've got to do there. Now it says find the area of the shaded region bounded by the curve and the coordinate axes. That means the the x-axis and the y-axis. So what's the shaded region? Yeah, so it's already shown here in shaded like this. We need to find this shaded region. How can we do that? How do we describe the shaded area? We could say this is area between the curve and the x-axis. We could also say it's the area between the curve and the y-axis. We could look at it both ways. Let's do it with the x-axis because we've got y as the subject and we already have found integral of y in the first part. We've done this integration already, so we could use that. What are going to be the limits? Limits are going to be from 0 to m. M is 1 over 2. So just integrate, input these limits, and that will give you this area. So area between the curve and x-axis. The formula for that would be integration of y with respect to x. In this case, the limits are supposed to be values of x, and they are from 0 to 1 over 2. Let's input those limits. 0 to 1 over 2. Now you've done this integration before. You don't have to do all of that again. That's why it's only 2 marks, because you've done this integration in the first part already. Let's put that function here. That integral that you have, 1 over 3 minus 2x, 1 over 3 minus 2x minus x squared over 2. Let's put that here. And input the limits from 0 to 1 over 2. Now let's input 1 over 2 first. That gives us 1 divided by 3 minus 2 into 1 over 2 minus 1 over 2 whole squared. Remember, this minus sign is outside the square. Do not put square on the negative sign. 1 over 2 whole squared divided by 2. That's what we get when we input x equals 1 over 2. Subtract from this the case when you input x equals 0. That gives you 1 over 3 minus 0 minus 0 squared over 2. That's a 0. Now let's simplify this. This gives us 1 over, or I can just put this in a calculator as well, not your choice. In this case, you could do it mentally as well. It's 1 over 2 minus 1 over 8 minus 1 over 3. Now put that on a calculator and see what that gives you. 1 over 2 minus 1 divided by 8 minus 1 over 3. That's 1 over 24. That's the area of that shaded region that we were looking for. Okay, that was quite straightforward. The whole question. Let me know if there are any problems with this. No questions? All right, good. Let's move on to the next one. So the next question, the question that you're asking about is question number 11. Okay, the curve has this equation. Y equals 3 cos 2x plus 2 for x between 0 and pi. What we need to do is we need to state the greatest and least values of y. Now, how can we do that? One very simple way of doing this is put this function in your calculator in the table function, 3 cos 2x plus 2, making sure your calculator is in radian mode. Take a small step. So you're taking values from 0 to pi. You could input something like, so you could say start at 0 and at pi and take a step of maybe pi over 8. And then see whichever y is minimum there and whichever y is maximum there. Just write those values there. That's one possibility. Or if you want to think of it logically, this is how you would go about doing this. You would say it's a cos function, right? Cos of 2x. What's the original period of the cos function? Original period is from 0 to 2 pi. That's when it completes one cycle. This period is from 0 to pi. Sorry, this interval given is from 0 to pi. However, the function is also cos of 2x. What happens when you do cos of 2x? What happens to the period? Cos of 2x? The period becomes half because of this, because this is horizontal stretch. When you do 2x, it's a horizontal stretch, scale factor 1 over 2. So the period that was earlier is 0 to 2 pi, now that period becomes 0 to pi. What that means is, within this interval, cos is completing one full cycle like this. So the cycle of cos is completing in this interval. If the cycle of cos is completing, which in this case is completing, we can say for a complete cycle, cos would have values between -1 and 1, right? So all we have to do is, we can say these are the extreme values for cos. Inside that function, you input -1 once and see what your function becomes. In place of put -1 in place of cos of 2x. What does that give you? 3 into -1 plus 2. And that gives you a value of -1. And then in place of cos 2x, you put 1, and that gives you 3 into 1 plus 2, which turns out to be 5. And now you say, this is the least value, and this is the greatest value. Okay, just input 1 in place of cos 1, then input -1 in place of cos 1. Why? Because the interval for cos is from -1 to 1, right? That's the range of cos. These are the minimum values, minimum maximum values of the cos function. So just input those extreme values here, and that gives you the corresponding extreme values for y. Okay, that's the first part. And the second part, you have to make a table on your calculator anyway. So you can do that for the first part as well. Now it says sketch the graph, right, for x between 0 to pi. How can we do that? The simplest way of doing this is, remember what the shape looks like. Shape of cos graph looks like this. For a complete cycle, this is what the shape is. If it's reflected, then it would look like this. But it's going to be one of these two shapes. There's nothing else that you can get. Okay. Now, all you have to do is put this function in your calculator, plot the points, and then just join those points using a curve like this. Okay. Okay, Mariam, can you please send me a message on the group? You can do that right now so that I remember that. I'll send you a link to a video that covers the table function, how to use the table function. Okay, or you can just search that on YouTube. It's a very simple thing. You'll find a 2-3 minute video on that somewhere. But I'll do that. If you just message on the WhatsApp group, I'll respond there. Okay. All right. Now let's make this table on our calculator. Okay, so this is the y-axis, this is the x-axis. X values have to go from 0 to pi. Okay, let's break it down. This is pi over 2. And then you have two values here. This will be 3 pi over 4. No, this will be 3 pi over, this will be pi over 4. And this will be 3 pi over 4. Okay, vertically, you know, -1 is the least value, 5 is the greatest value. When you put values in the table as well, you would see that -1 is the least value and 5 is the greatest value. So you have to go up to 5 here on the vertical axis. Then you could say this 1, 2, 3, 4, and 5. Okay. Now let me just do this, make this table on my calculator and see what that gives me. Make sure your calculator is in radian mode because the angle is in radians here, and then make the table. Okay, so it's 3 cos of 2 times x plus 2. That's the function. Start at 0, end at pi, step of pi over 4. So we have enough values to be able to figure out the shape. Okay, now the first value that I'm getting at 0 is 5. So it starts at 5, and then it goes to 2, and then pi over 2 is -1, then 2 again, and then 5 again. These are the points that they get. Now, if you remember the shape, you can draw the graph. Once you have these values, you would know that the cos graph is going to look like this. It will go like this here, and then go like this. And then on the other side as well, it will be something like this here, and then like this. This is what the cos graph is going to look like. Okay. If you do not remember the shape, you would need to take a smaller step in that case. You will need some additional values. So that's why remembering shapes really helps, because you can just take a few points, and then since you remember the shape of the graph, the general shape of the graph, you can make that shape using those points. If you do not remember the shape, the step that you take on your table function, make that pi over 8, you will get some values in the middle as well. You will get a value here somewhere, then here somewhere, and then here and here. And then you would understand, okay, this is how the shape of the graph is going to look like. If you still can't understand that, make the step even smaller, but you should be able to understand that. You need to remember at least a rough shape for the cos function. This is what the graph is going to look like. Okay, now it says, by considering the straight line y equals kx, where k is a constant, state the number of solutions of the equation 3 cos 2x plus 2 equals kx for x between 0 and pi for each of the following cases. Okay, now let's think about this. Cos 3 cos 2x plus 2 equals kx. Okay, now in the first two parts, we have been dealing with this function y equals 3 cos 2x plus 2. That's what you have on one side of this equation. What's the other function on the other side? This is kx y equals kx, right? That's the other function. Now, if the value of k is minus 3, what does that mean? It will look like this, y equals minus 3x, right? That's what this line would look like. Now, you see, the y-intercept of this straight line is 0 because there's no constant term, right? There's no constant term. So this line has to pass through the origin. So all of these lines, they are going to start from the origin. They will start here at the origin. Okay. And now from the origin, in which direction is this line going to be in? Y equals minus 3x. That's a negative gradient. So the line is going to look like this. How many solutions do you have here? Well, you can see this line is not really intersecting the curve. So for the first part, we say there are no solutions, right? Because the line does not intersect the graph at any point, okay? The curve at any point. Now, what's the second function? The second function is y equals x. Now we need to be careful because now the gradient is 1 now. How is this graph going to look like? Remember, the gradient is 1. If the gradient is 1, it's going to be positive gradient like this. Now, how do we know if it's going to go like this or it's going to go like this? Because in one case, it would intersect at 1 point. In the other case, it would intersect at 2 points. So we're not sure about that. So how do we figure that out? We are only concerned with this interval from 0 to pi. Now we know the line is going to pass through the origin. The other point that you take, you should take that at the other extreme end, pi, right? This is pi. At pi, if the equation is y equals x, if the x value is pi, what is the y value going to be? The y value is also going to be pi, right? So what's that point going to be? Pi and pi, that lies on this line. Now, on the vertical axis, we've got these numbers 1, 2, 3, 4, 5. What's pi? Pi is 3.14. So that value at pi is going to be somewhere here. This line would look like this, the y equals x line. Now, how many points is this line intersecting this curve? It's intersecting at 2 points. So you would say there are two solutions now when k equals 1. And then finally, in the last case, it says the value of k is 3. So now the line is y equals 3x. How is this going to look like? Y equals 3x means if the x coordinate was pi, the y coordinate would become 3 pi. So that becomes pi and 3.14 into 3. 3.14 into 3, what's that? 9.42. Where is this point going to be? It's going to be way above somewhere, right? So maybe somewhere here. So this last line, y equals 3x, line would look like this. It would go like this. Now this line is only intersecting at 1 point. It's only intersecting at this point. So in the last case, we say there's only one solution. Okay. Now let me repeat that. Remember, we were looking for the number of points of intersection of these two graphs. One graph was already drawn there. That was the curve that we had. The second graph that you have to draw is a straight line, y equals kx. Now, it has to pass through the origin because you can see the y-intercept is 0. How do you find another point on the line? If the value of k is 1, that means it's y equals x line. How do we draw these lines? How do we draw any straight line? We take 2 points on that line. 1 point is the origin. That's something that we already know. That's here. Let's take one more point. What we do is we take another point on the other extreme of the interval that we're given. The interval is until pi. So we see what's another point going to be on this line. If x is pi here, what about the y coordinate? Y is also going to be pi. Since on the vertical axis, we have values written like this, 1, 2, 3, 4, and not in terms of pi, we can write it in numbers like this. We can say this point is basically 3.14. Let's mark that point. That point came out to be here. And that tells you that when you draw a line from origin like this, it intersects the curve at 2 points. And similarly, for the case when k equals 3, that only intersects at 1 point. So you say in the second case, you've got 2 solutions. In the last case, you've got 1 solution. Is that okay, Rajal? Okay, any questions on this? Make sense to everyone? Okay, that was the, yeah, so you just have to draw the line and then think using that, right? In the second case, it was intersecting at 2 points. And you only find that out by drawing those lines, okay? So in the graph that you drew in the earlier part, you just draw these 2 lines to try to understand how many points of intersection you get from that. All right, let me actually just leave it like this, in fact, for the notes later. Okay, that was part C. Now it says functions f, g, and h are defined for all real values of x. X belongs to R means they are defined for all real values of x. Describe fully a sequence of transformation that maps the graph of y equals f of x onto y equals g of x. Okay, so f of x is, okay, f of x is going to f of 2x plus 4. There are 2 transformations that are happening. There's one horizontal transformation that's happening inside the function. There's one vertical transformation that's happening outside the function. What's the transformation that's happening inside? That's a stretch. Outside is translation. Now, in horizontal and vertical transformations, the order does not matter. You can do any of them first. So you can start with 2x, for instance. You would say one transformation is horizontal stretch, or you could say stretch along x-axis. With scale factor 1/2. And then the second transformation is a translation. It's a vertical translation, 4 units upwards. You have to write down a vector for this. The vector would look like this, 0, 4. That's the vector, okay? There's no movement on the horizontal axis. In the vertical axis, we say we are moving 4 units up. That's all that you have to do here. You can reverse this order as well, and it would not matter because one of these transformations is horizontal and the other is vertical. So it doesn't matter which one of the 2 you do first. Okay, now it says describe fully a sequence of transformation that maps the graph of y equals f of x onto h of x. Okay, so f of x is now going to h of x, which is this, 2 into f of x plus pi/2. Now again, we've got 2 transformations, one horizontal, one vertical. So there's something happening outside here, something happening inside here. Multiplication by 2 outside. What does that mean? That's a vertical stretch, or you can say stretch along y-axis with scale factor 2. And inside you've got a translation. It's a horizontal translation. Remember, in horizontal translations, it works the other way around. So if it's plus pi over 2, that means you're moving pi over 2 units to the left. So what would the translation vector be? Minus pi over 2 and 0. That will be the translation vector. It's necessary to write down a vector here. They do not allow describing this in words. That is not allowed. It used to be accepted earlier. So this is a 2020 paper. So in this case, they might write in the marking scheme that you accept if the candidate says it's a translation pi over 2 units to the left, but they do not accept this anymore. They want you to write down vectors like this. Without a vector, you would not get full marks. Okay. All right. So that's this transformation. And that's it. That was question number 11 from this paper. Okay. So we're done with this first paper. This was November 2020 paper 1, variant 2. Let's have a look at the other one now. Again, if you haven't voted in that other poll yet, please do that. For now, I see 3 questions from that. Question number 5, 7, and 11. If there are any other questions as well, do let me know by voting there. So I see how many people have problems in those questions. Okay, all right. Let's move on to the next paper now. Okay, so the next paper that we want to discuss is this. This is November 2020, paper 1, variant 3. From this, we want to do 3 questions, 5, 7, and 11. Right? Yeah, 5, 7, and 11. Let's start with this. Okay. Question number 5. It says, in the expansion of a plus bx whole raised to the power 7, where a and b are non-zero constants, the coefficients of x, x squared, and x raised to the power 4 are the first, second, and third terms, respectively, of a GP. Find the value of a over b. Okay. Now, how do we think about this? First of all, let's focus on this part. They are talking about coefficients of x, x squared, and x raised to the power 4. Let's first find those 3 coefficients. What's the expansion that we need to do? A plus bx whole raised to the power 7. The formula looks like this. A plus b whole raised to the power n. That is a raised to the power n plus nc1 a raised to the power n minus 1 into b plus nc2 into a raised to the power n minus 2b squared, and so on. Let's input values in that formula. A raised to the power 7 plus a raised to nc1, that means 7c1 into a raised to the power 6 into bx raised to the power 1 plus 7c2 into a raised to the power 5 into bx raised to the power 2. We've got the x term and we've got the x squared term. We also need x raised to the power 4. Let's expand it a bit more. Then you have 7c3 into a raised to the power 4 into bx whole raised to the power 3. And then finally, we have 7c4 into a raised to the power 3 into bx whole raised to the power 4. You've got x power 4 term here as well. And that's where you stop. You don't have to expand it any further. These were the only 3 terms that we were interested in. This one, and this one. X power 1, x power 2, and x power 4. Let's simplify each of these terms and see what we get from them. 7 into a raised to the power 6 into bx. That gives us 7a raised to the power 6 times b times x. Okay, then the next one is 7c2. What's 7c2? 7c2 is 21. 21 a raised to power 5 b squared into x squared. And then we have this term, that's 7c4. 7c4 is 35. So this one is 35 into a raised to power 3, b raised to power 4, x raised to power 4. Okay? Now what they're saying is, the coefficients of these three terms are the first, second, and third terms respectively of a GP, of a geometric progression. So we've got a geometric progression such that its first three terms are these. 7a raised to power 6 into b, that's the first term. 21 into a raised to power 5 b squared. And 35 a raised to power 3 into b raised to power 4. That's T1, T2, and T3. These are the first three terms of this GP. Now, since it's a geometric progression, it's supposed to have the same ratio throughout, right? So we can say the ratio of these, the ratios of these terms can be found like this. We could say T2 over T1, that would give us the ratio of these, of the GP. Ratio could be found like this, T2 over T1. The ratio could also be found like T3 over T2. We could also divide these two terms to get the ratio. So basically, we get an equation like this from this. We get 7, or in fact, 21 a raised to power 5 into b squared divided by 7 a raised to power 6 times b. That should equal 35 a cube into b raised to power 4 divided by 21 a raised to power 5 into b squared. This is what we get. So we've got an equation like this. Now let's simplify this. A and b are non-zero constants. That means we can do any cancellation wherever needed, right? We can divide by a and b as well because they cannot be zero. So division by 0 would not be a problem here because we can't divide by 0. Basically, a and b cannot be 0. We would not run into that issue of division by 0. Let's simplify both sides a bit. 21 over 7 on the left side, that gives us 3. Then we have a power 5 here, a power 6 here. What does the power of a become? 5 minus 6, that's a power minus 1. B squared and b raised to power 2 minus 1, that becomes b raised to power 1. On the right side, we've got 35 over 21. How does that simplify? I think that's 5 over 3, right? Yeah, 5 over 3 on the right side. A cube over a raised to power 5. A raised to power 3 minus 5, that gives us a raised to power negative 2. And then b raised to power 4 minus 2, that is 2. And now what are we looking for? We are looking for the value of a over b. Let's take a terms to one side and b terms to the other side. Sorry, a and b terms to one side and constants on the other side. If we take b squared to the left and a to the left as well, we get something like this. A power minus 1 into b raised to power 1 divided by a raised to power minus 2 into b squared. Let's take this 3 to the other side, and that will give us 5 over 9. And now you'll see on the left side, when this minus 2 goes to the numerator, it becomes plus 2. So a raised to power minus 1 plus 2, that gives you a raised to power 1. Into b raised to power minus 1, you can actually take this term to the denominator, and that will give you a over b. And that's what you're looking for. A over b equals 5 over 9. That's the value that we were looking for. That's a over b. Now, you need to be comfortable with indices here. Some people struggle with indices, and that's something that you should work on. That's something that's an O-level thing that you need to get comfortable with. Otherwise, you can lose easy marks like this. Okay, make sense? A over b equals 5 over 9. That's the final result that we get. Okay, so that was question number 5. Let's move on to the next one. The next one is question number 7. It says, the first and second terms of an arithmetic progression are 1 over cos square theta and minus tan square theta over cos square theta respectively, where theta is between 0 and pi over 2. Show that the common difference is this. Okay, so it's an arithmetic progression. And the first two terms look like this: 1 over cos square theta. And then the second term is minus tan square theta divided by cos square theta. Okay. Theta is between 0 and pi over 2. Show that the difference is this. How do you find difference of an AP? Next term minus the previous term. So difference would be minus tan square theta over cos square theta minus 1 over cos square theta. Subtract from the second term the first term. Okay. And now we need to somehow simplify this and show that it becomes this. How can we do that? Let's take LCM. And when you take LCM here, that is going to give us minus tan square theta minus 1 whole divided by cos square theta. Okay. Now we want cos raised to power 4 theta in the denominator, and in the numerator we've got tan square theta. Now remember that identity between tan square and secant square. We could write. In fact, we're doing paper 1, right? Okay, so we don't. So most of you would not know about that identity that we do in paper 3. That will actually make this very quick. But okay, so those of you who are doing composite, you could actually do that since you've done paper 3 as well. If you know about that identity, 1 plus tan square theta, that's identical to secant square theta. You could actually convert it to secant square, and you would get something like this from that, minus secant square theta over cos square theta. And then just take that to the denominator, and it could be written as minus 1 over cos raised to power 4 theta after this. Okay. So that could be one possibility. So if you know this identity from paper 3 already, you could use that. If not, then if you're in AS right now and have not done paper 3, then you might not know that. In that case, what you can do is, since you want cos at the end and no tan, you can write tan as sine over cos first of all, and see what that gives you. Minus sine square theta over cos square theta minus 1. And in the denominator, you would have cos square theta. Now in the numerator, in fact, it might make things a bit simpler if you take minus common here. So we don't have to write that minus again and again. I'm taking minus common. So inside I'm left with sine square theta over cos square theta plus 1. Is that okay? All right, I've just taken minus common outside. And that leaves me with tan square theta plus 1, which is sine square theta over cos square theta plus 1 like this. Okay, now let's take LCM in the numerator. Let's take LCM there. What does that give us? Sine square theta plus cos square theta divided by cos square theta. Right? I've just taken LCM there in the numerator. And whole divided by cos square theta. It turns out this was also not that long. So, because now we've got in the numerator sine square theta plus cos square theta. So that's 1 over cos square theta, because sine square plus cos square is 1. In the denominator, we've got cos square theta. Now we can just take this cos square to the denominator. And that would become minus 1 over cos raised to power 4 theta. And that is what we had to prove here. That's the same as the right hand side. All right, so that's how you could prove this identity. Make sense? That was the first part. Now let's move on to the next one. Now it says find the exact value of the 13th term when theta equals pi over 6. So now we know the first two terms. This was an arithmetic progression. And the first term was 1 over cos square theta. Let me write that here. That was the first term. We have also found the difference now, or we have proved that the difference is minus 1 over cos raised to power 4 theta. We've proved that. So difference is minus 1 over cos raised to power 4 theta. Let's input those values in this now. Input the value of theta in this now to find the value of A and of B. Let's see what we get from that. You put theta equal to pi over 6. Now, what do we get from this? A equals 1 over, remember, cos square theta is the same thing as cos theta whole squared. And cos raised to power 4 theta is the same thing as cos theta whole raised to power 4. I'm sorry, what did I write there? Cos square theta is the same thing as cos theta whole squared. And cos raised to power 4 theta is the same thing as cos theta whole raised to power 4. Okay, they're the same thing. So what do we do here now? We say it's cos of pi over 6 whole squared. And this is minus 1 over cos of pi over 6 whole raised to power 4. Now, whenever you get something like this, and you have to write down, you have to find an exact value of something, you need to make sure that you show the step where you are inputting the value of cos pi over 6. You do this on your calculator, that's perfectly okay. But write this value down first of all. What's the value? Cos of pi over 6. Write that value down from your calculator. That's under root 3 over 2. So it's under root 3 over 2 whole squared. And now you simplify this, it becomes 1 over 3 over 4. And the first term is 4 over 3. You've got the first term. Similarly, find the difference in terms of under root 3, or maybe just an exact value, however, whatever it turns out to be. Let's find the exact value of the difference as well. Minus 1 over cos of pi over 6. What's that? That's under root 3 over 2 whole raised to power 4. Put that on a calculator and see what that gives you. Under root 3 over 2 whole raised to power 4. And that's giving me 9 over 16. And the difference turns out to be minus 16 over 9, therefore. That's the difference. And now what are we looking for? We are looking for the 13th term. It's an arithmetic progression, T13. What's that going to be? A plus n minus 1 times D is 4 over 3 plus n minus 1. That means 13 minus 1, which is 12, into the difference, which is minus 16 over 9. You can evaluate this and see what that turns out to be. 4 divided by 3 plus 12 into minus 16 divided by 9. And that's giving me minus 20. Okay, is that correct? Is that what we get? Okay, good. So that's the 13th term. All right, minus 20. Okay, let's move on to the next one. This was question number 7. And now the next question that you're asking about is question number 11. Let's try that now. Question number 11 from this paper. Okay, now this says a circle with center C has the equation x minus 8 whole squared plus y minus 4 whole squared equals 100. Show that the point P, which is minus 6 and 6, is outside the circle. Now, how can you show this? You have a circle, and let's say this is the center. For any point to lie inside the circle, let me actually write down the points here. So you've got this equation of the circle. What's the center of the circle? The center of the circle is 8 and minus 4. You just flip these numbers. This is minus 8, flip their signs, it becomes 8. Sorry, 4, 8 and 4. So these were 8 and minus 8 and minus 4. You flip their signs and make them 8 and 4. Why? Because this is the standard form, x minus a whole squared plus y minus b whole squared equals r squared. What about the radius? Radius is going to be square root of 100, which is 10. So we know the center and we know the radius. Center has coordinates 8 and 4. Now, for any point to lie inside the circle, its distance from the center has to be less than 10. Because if the distance from the center is less than 10, that means this distance is 10. If there's another point that has a distance less than 10, that will lie inside the circle. And if there's a point that has a distance of more than 10, that will be outside the circle, right? So all we have to do is find the distance of that point T from the center of the circle. And the center has coordinates 8, 4, and it's named C here. All you have to do is find this distance, CT, and see what that turns out to be. X2 minus x1 whole squared plus y2 minus y1 whole squared, right? So it's 8 minus 6, that becomes 8 plus 6 whole squared plus 4 minus 6 whole squared, and then square root of that. What do we get from this? 14 squared plus 2 squared, that's 200. So this is square root of 200, which turns out to be 14.14. That's the distance of the point T from the center of the circle. Now we say, since CT is greater than the radius, distance of the point T from the center is more than the radius. 14.14 is greater than 10. That means T lies outside the circle. Okay, because if the distance from origin is a distance from center is 14, radius is just 10, that point has to be outside the circle. Okay, all right, that's the first part. Now it says two tangents from T to the circle are drawn. Show that the angle between one of the tangents and CT is exactly 45. Okay, now sketching is really important in problems like these, in circle equations questions. It's very important to draw a sketch, and that sketch should be reasonably accurate, because that will help you figure out any unknowns in the question. If you don't have a good sketch, you'll find it hard to figure out what they're asking for, in some cases at least. So draw a good sketch that helps you understand the situation. So what are we talking about? We've got a point C that is the center of the circle, that's here. What else are we given? We know the radius of the circle, that is 10. And there's a point T that is -6 and +6. Now think about it. Where is this point going to be? -6 and +6. X coordinate is -6. This X coordinate is 8. And that X coordinate is -6. So that it's going to be to the left of this point. Somewhere to the left, right? Maybe somewhere here. Here, somewhere here. What about the Y coordinate? The Y coordinate of T is 6. And the Y coordinate of the center is 4. So it should be above this point. So to the left and slightly above. All right? Because the coordinates of T are -6 and +6. So difference between the X coordinates is quite big, but the difference between the Y coordinates is not that big. So it should be left and above the center. Okay. Now, radius of the circle is 10 units. So until this point, it's already -2. So a few units more, it might be somewhere here. Let's call this point T. No, not this point, slightly above as well. So maybe here. Let's say T is here. Now, you don't have to be very accurate here, but it should be reasonably accurate to help you understand the situation better. So let's say this is the point T. Okay, to the left and slightly above, this is -6 and +6. And now what's happening is you've got two tangents coming to the circle from T. So you draw one tangent on one side, it may be like this, and another tangent on the other side, it may look like this. You've got these two tangents coming from outside the circle. And now what they're saying is, show that the angle between one of the tangents, so choose any one of them, and CT. What's the line CT? CT is the line that joins the center with this point. That's this line. This is CT. This is something that you should always do. Whenever you have two tangents coming from outside a circle, you should always join this point with the center as well, because remember that circle property, this shape that you get is a kite generally, right? So this shape looks like is basically a kite. It's always a kite, right? That's a general rule that we've got. Because this angle is 90, and this is also 90. And these angles are equal. This angle is equal to this, and this angle is equal to this. All right, so that's something that we know about. Now we want to find the angle between one of the tangents, that means maybe this tangent, and the line CT. So this is one tangent, and this is the line CT. What's the angle between them? The angle between them is this angle here. How do you find this angle? Let's call this angle theta. What do we know about this right angle triangle? We know that this length is 10. This is the radius. Do we know anything else? We know the length CT as well, in fact. We have found that earlier. That is 14.14 or square root of 200. We know that as well. So we can just use simple trigonometry for this. 10 and square root of 200. 10 is perpendicular, the side opposite to the angle. Under root 200 is hypotenuse. So we can say perpendicular or hypotenuse is sine. So sine of theta equals perpendicular, which is 10, over the hypotenuse, which is square root of 200. And that's going to give us the value of theta. You can see what that turns out to be. Sine inverse of 10 divided by under root of 200. I'm getting pi over 4. My calculator is in radian mode. You need to convert that to degrees first, because they're asking for the angle in degrees here. So that's when you should convert your calculator to that mode. So it's turning out to be 45 degrees, and that's what we were looking for. Theta equals 45. Okay. Now it says the two tangents touch the circle at A and B. So they're saying this point is A and this point here is B. These points are A and B. Okay. Find the equation of the line AB, giving your answer in the form y equals mx plus c. Okay, so we want to find the equation of this line AB. Okay. Now, how do you find the equation of a line? You need two things for that. You need the gradient of the line, and you need any one point that lies on the line. Now, the problem is we don't have the gradient, and we don't have a point. We don't know what the point A is, what point B is, and we also do not know the gradient of this line. Okay, now let's think about this. Can we somehow find the point A or the point B? Can we find these points? One possibility could be that you have the equation of the circle already. Equation of the circle is given. Equation of the circle is given. And if you can somehow find the equation of this tangent, but how would you do that? You have a point on that tangent, but you do not have the gradient of the tangent. You don't have the gradient of the tangent? Do we have that? We don't. Okay, so finding the equation of the tangent is going to be quite complicated. So one possibility could be to find this point by solving the equation of the circle and the equation of the tangent simultaneously. Once you have those 2 points, you could find the gradient of that, and also then just write down the equation, but that will take quite long. It's only 4 marks, so there should be some other way of thinking about this. What they've done is they've made us calculate the angle in the previous part, that is 45. So if that angle is 45, let's write that here. This angle is 45. Now this angle is 45. The angle below is also going to be 45. This angle is also 45 because remember it's a kite. Since it's a kite, these two angles are going to be equal. That means this total angle is basically 90 degrees. And if this is 90, this is also 90. All of these angles turn out to be 90. Okay, I'm sure you're saying, can we take the midpoint of CT and gradient of CT? Midpoint of CT. Okay, so that is what we will be doing eventually. Yes, in this case, since the angles are now 90, that's what we will be doing. But can somebody explain that to me? How can we say that this point is going to be the midpoint of AB and CT? How can we be sure about that? In fact, on the diagram that I have drawn, it does not look like it's passing through the midpoint. How do we know that? We can't assume. We can't assume anything. Okay. However, if you think about this, since we know, now this is important, since we know this angle is 45 and this angle is also 45, this complete angle is 90 then. Now, since this complete angle is 90, this complete angle is 90, and we know the other angles on the other side, angle at A and angle at B, they're already 90. Why? Because they're radius and tangent. The opposite angle, this remaining angle, that's also going to be 90. So basically, what we understand from that is that the shape, the quadrilateral that we have, it has all angles 90. All angles 90. What kind of a shape is that? That's generally a rectangle. Okay. Generally, that's supposed to be a rectangle like this if all angles are 90. However, in this case, since we know that this length is 10 and this is also 10 and all the angles are 90, instead of being a rectangle, it's actually a square because the sides are also equal. The angles are all 90 and the sides are all equal because of these sides are 10 and the angles are 90. The other sides are also supposed to be 10 then. Okay, because in a rectangle, if this side is 10 and this side is 10, that means all sides are 10 because the opposite sides have to be equal to each other. So it's actually a square. Okay, let me write that down here. So in this case, the figure ACBT is basically a square. Now, what does that mean? If ACBT is a square, let me draw that square here. It looks something like this. It's a square roughly like this, where this point is A, this point is C, this point is B, and this point is D. And we know the sides are 10. What we are looking for is the equation of the line AB. This is the equation that we are looking for. Now remember the property of the diagonals of a square. The diagonals of a square, they meet at midpoints and they are also perpendicular to each other. Diagonals of a square, you need to know all of these properties for diagonals of quadrilaterals. So basically, for a square, the diagonals are equal, they meet at midpoints and they are perpendicular. So basically, in a square, the diagonals are perpendicular bisectors of each other because they are perpendicular and they also meet at the midpoints. Both of those conditions are true. Okay. So now that we understand that, now when we go back to that, since it's a square, that means line AB is actually going to be a perpendicular bisector of the line CT, because the diagonals in a square are perpendicular bisectors of each other. So now we know the coordinates of C. The coordinates of C were 8 and 4, and the coordinates of T are -6 and 6. Can we find the perpendicular bisector of CT? Let's find the gradient of CT. What's that going to be? 4 minus 6 divided by 8 plus 6, and that gives you 2 over 14, which minus 2 over 14, which is minus 1 over 7. What about the gradient of AB then? That will be negative reciprocal of this. That's 7. So we've got the gradient of AB. And then what about the midpoint of AB? Midpoint of CT, in fact. What does that turn out to be? Minus 6 plus 8 over 2 and 6 plus 4 over 2. The midpoint turns out to be 1 and 5. This is the point M that we have marked on the diagram. And this is the gradient of AB. We can write down the equation of the line AB now. We can say the equation of AB is y minus y1. That's y minus 5 equals m, which is 7 into x minus 1. And that's, since they want your answer in the form y equals mx plus c form, we can say that's y equals 7x minus 7 plus 5, which simplifies to y equals 7x minus 2. That is the equation of the line that we were looking for. Okay. So yes, this was the midpoint of the line AB as well. And since it's a kite, this angle was going to be 90 degrees. And in fact, eventually it became a square. So in a square as well, the angles of the diagonals are 90 degrees. We can use those two pieces of information that the midpoint M of CT is also the midpoint of AB. So that lies on the line AB. And AB and CT are perpendicular, because diagonals of a kite as well as a square, they are perpendicular. Since it was a square, we used both of those properties, that the diagonals were perpendicular and they met at midpoints, to find the equation of the line AB, right? But in order to be able to use that, how did you figure out that ABCD is a square? Let me just repeat that. We proved in the previous part that this angle was 45. If that angle was 45, the other angle is also supposed to be 45, right? Both of these angles are 45. What's the total? The total is 90. So that means this angle here at the point T, this point, this is 90. Now, angle A was already 90 because that was radius and tangent. Angle B was also 90 because that was also radius and tangent. 3 angles are 90. What about the 4th angle then? That's also supposed to be 90. All angles are 90. And we know this is radius, both of them are equal. Adjacent sides are also equal. Angles are 90, all sides are equal. What's that shape? A square. So we know it's a square from that reason. Okay. Diagram is not going to be checked, as in you won't get marks for the diagram. However, it's going to be very hard to figure this out without drawing a diagram. Okay, so you should always draw a diagram. Try to make it roughly fairly accurate as much as you can without spending too much time on this. And that will help you with the calculation, because in this case, if we had not drawn that diagram, it would become very difficult to figure out what they're talking about here. Okay, but you will not get marks for drawing the diagram. That's for your own self. You should leave that there. But it's you will need to draw it, right? It's going to be hard to figure it out without drawing the diagram. And that's okay if it's not looking like a square on this diagram. That's perfectly okay. That's not a problem. You're just doing this for your own working. Okay. They're only going to be checking this part. Okay, now let's look at the last part now. It says, find the x coordinates of A and B. So now they ask you to find the points A and B. Okay, how can you find the points A and B? The x coordinates of these points A and B are basically points of intersection of this line AB that you have just found and the circle. So you just solve the equation of the circle and the equation of the line AB simultaneously, and that's going to give us the coordinates of the points A and B. Okay, let's do that. Let's solve these two equations simultaneously and see what we get from that. The equation of the circle was this: x minus 8 whole squared plus y minus 4 whole squared equals 100. That was the equation of the circle. And equation of the line was y equals 7x minus 2. We just found that. Just solve these two simultaneously and see what that gives you, because A and B are the points where the circle and this line, they meet each other. So what do we do now? We just put this in this circle equation, right? Y equals 7x minus 2, and see what that gives us. X minus 8 whole squared plus 7x minus 2 minus 4 whole squared equals 100. Let's simplify this. X squared minus 16x plus 64 plus 7x minus 6 whole squared equals 100. X squared minus 16x plus 64 plus 49x squared minus 2 into 6 into 7. That's 84. 84 times x plus 36 minus 100 from the other side. That equals 0. And we get this quadratic equation from that: 50x squared, and then minus 16 minus 84, and that's it, minus 100x, 64, 36 minus 100. That's going to be 0. So the constant terms cancel out. Yeah, so this is all that we're left with. You can divide the whole equation by 50 to get x squared minus 2x equals 0. Take x common. X into x minus 2 equals 0. That means either x equals 0 or x equals 2. These are the x coordinates of the points A and B. Since we can't figure out which one of the 2 points is A, which one of the 2 points is B, we can just leave it like this, and we can say one of these points is going to have x coordinate as A and the other is going to have B, because, yeah, so we only know that the tangents touch the circle at A and B. We could have this as A or this as B. We could interchange the points as well. So we can't specify that this is the coordinate of A and this is the x coordinate of B. This is just going to be the final answer. One of them is 0 and the other is 2. Okay, we'll just leave it like this. That's the last part. Okay, makes sense? Any problems with this? Any questions, anyone? No problems? All right, good. That completes our paper then. In our next class, we will be doing difficult questions from two of the 2022 papers, most likely. I'll tell you which ones. On Thursday, we will most likely be doing difficult questions from 2 November 2022 papers. Okay. And then we'll come back to 2020 again on Friday. Okay. No questions, no problems. All right. So the no problems, that's it for today. I'll see you again on Thursday for the next P1 Plus. Allah Hafiz.